Hello everybody, and welcome to Ancient Architects. Please subscribe now to get the latest ancient history news and independent research from around the world. This year I was lucky enough to visit the Giza Plateau and explore the pyramids and their associated structures and stonework. And on the eastern side of the Great Pyramid, you can't help but take note of the basalt pavement, which really looks magnificent. These paving stones are all that remains of Khufu's mortuary temple, which could have been destroyed at the same time the pyramid's casing stones were removed, if not long before. The basalt blocks, situated in a central position on the pyramid's eastern side, are beautiful, and they once paved the temple's great court, which had walls made of limestone with 38 granite pillars erected inside. When excavated in the 1930s, Selim Hassan did find the remains of some of these pillars, mostly square in section but some rectangular, and today we can still see the sockets where these pillars were once placed. So, Khufu's temple had a black basalt floor with red granite pillars and white limestone walls, which were most likely adorned with colourful reliefs, and it would have been quite a sight to behold. But alas, all we have today is this pavement, and this is a favourite talking point for those that believe in a lost ancient high technology in ancient Egypt. It's a hard igneous rock, and we can see some specific cut marks on some of the rock faces. So, how were they made? How was this rock cut and shaped? Was it even possible with the materials and technology of the day? Is this basalt pavement still hiding ancient secrets? Just how difficult was it to work? Let's take a look. Basalt was initially used in Egypt for small vessels in the late pre-dynastic period, and was first employed on a monumental scale in the Old Kingdom, for pavements in numerous pyramid temples. Fragments of basalt paving were found in the 3rd dynasty step pyramid of Djoser, although these were not found in situ. They were also found at the 4th dynasty Great Pyramid, as we've seen, and the 5th dynasty pyramids of Usakaf, Sahore, Neferikare and Niesere. Although it had a number of uses from site to site, it is often used as a paving stone. But why? Well, there is no consensus, but it's possible it's all because of the rock's dark colour, as some believed it symbolised the dark, life-giving Nile mud, which identified with the god Geb. It was a commonly used building stone all the way up to the First Intermediate Period, aka the end of the Old Kingdom. The use of basalt comes under the spotlight because it is a hard rock. It's igneous, not a soft sedimentary rock like limestone, and it was also not a native rock found naturally in the necropolis sites of Lower Egypt. It had to be quarried, transported, worked and placed, and none of this work is easy. Whether it was transported over land or via the Nile River, we really don't know. But however it got to its destination, there is still a body of thought that the Old Kingdom Egyptians couldn't work it effectively, that the technology available doesn't explain the saw cuts on display, and that also the tools were not up to the job. So, with a background in geology, I wanted to take a closer look at the basalt pavements of the Old Kingdom. So I don't lose viewers with geology jargon-filled sentences, I'll start at the beginning. What is basalt? Well, it's an extrusive volcanic rock with a fine-grained crystalline texture, meaning it forms from rapid cooling of molten rock. Its composition differs from source to source, and this can greatly affect the properties of the rock, including its hardness and durability. Natural outcrops of basalt also weather quite quickly, far more so than granitic rocks, because the minerals that form it are less stable in colder, wetter conditions at the Earth's surface. A weathered rock is easier to work, but obviously it doesn't give a good finish. Natural basalt exposures are found throughout Egypt, varying in size and the quality of the rock, but due to the amount that was used in the Old Kingdom, the quarry we're looking for must have been quite large. To pave so many temples, we need to find large outcrops of good quality basalt, it would have been a major effort in the day. The only basalt source where there is evidence of Old Kingdom quarrying on a grand scale is at the Jebel el-Qatrani geological formation in the northern Fayum, around 58 kilometers from Giza. The formation is a sequence of 3 basaltic lava flows. The basal and top flows are deeply weathered and vesicular, meaning the rock is full of holes, and these form from the gases escaping as the lava cooled down. The middle layer, which in places is 15 meters thick, is dense and comparatively unweathered, and hence this was the rock that was used in the Old Kingdom. It displays poorly developed columnar jointing, and hence we can see numerous natural fractures running through the rock, but these fractures actually make it relatively easy to quarry. There are 2 Old Kingdom quarries identified as Jebel el-Qatrani, and these are located at Widden el-Faras, labelled east and west on this diagram, and pottery shards from the Old Kingdom have been found in abundance. The excavated rock was taken from around 3 to 5 metres below the original surface and 5 to 10 metres back into the hillside, and this was so workers could access the unweathered stone. As stated, the basalt is naturally fractured, and so to quarry the rock, chunks of it were likely just wedged out of place with levers. From examining the quarry, the blocks extracted could have been no bigger than 2 metres in size, and this is consistent with what we see with the blocks in the Old Kingdom temples. At the Khufu temple, the slabs are typically around 70 centimetres long and 40 centimetres thick, with the largest being just 1.5 metres long and 0.5 metres in thickness. The blocks that were used in the Khufu mortuary temple can be seen to have many internal fractures, and, as stated, the exact same thing is seen with the natural rock in the quarry. Geologist James Harrell examined the quarry in detail and said that the rock was identical to basalt used at Giza, Saqqara and Abu Ruwash. The rock has been analysed petrographically as well. We do know the specific mineralogy, and I've not seen this discussed anywhere else online, and this is the key. The Great Pyramid basalt consists mainly of labradorite, augite and volcanic glass, with minor quantities of magnetite. We also find rare amounts of hornblende, olivine, quartz and apatite. There are also some large grains of labradorite, 7 mm across, but the ground mass, aka the bulk of the rock, is generally made up of grains smaller than 1 mm in size. There is also some weathering present, and this is seen from partial devitrification of the glass in the ground mass. From analysing the mineralogy and the chemistry of the rock, it's classified as normal basalt. So is normal basalt hard to work? Actually, and relatively speaking, this specific type of basalt that was used in the Old Kingdom pyramid temples is in fact quite easy to work. First of all, you can cleave it along the naturally occurring straight fractures, and this creates clean flat surfaces, ideal for making pavements and reducing the amount of manual shaping required. You can get somewhat regular pieces of basalt rock of a similar size and well faced. Of course, the edges of the rock did need some work so they could fit together like a jigsaw, but the flat surface could well be the rock's natural fracture planes. But cut marks and soaring striations have been noted, so how do you cut this hard igneous rock? Geologically speaking, hardness is not something you usually assign to specific rocks, as there is no typical basalt or typical granite, for example. The chemistry, the minerals, their percentages, the rock texture, the amount of weathering, the level of fracturing all vary. You can have porphyritic basalt and aphanitic basalt. You can have vesicular basalt and non-vesicular basalt, and the list of variables goes on and on. The Mohs scale of hardness is a scale from 1 to 10, and it relates specifically to minerals, and is characterised by their scratch resistance. A diamond at 10 can scratch corundum at 9, which can scratch topaz at 8, which can scratch quartz at 7, and so on. And although diamond is a 10, meaning nothing can scratch it, if you hit a diamond with a hammer, you can still smash it into pieces. Hardness does not equal toughness. But anyway, rocks are not generally characterised on the Mohs scale, and that's because they're an aggregate of different minerals. But a rough average can be estimated if you know its source and mineral assemblage. We know that the basalt used for the pavement in front of the Great Pyramid is predominantly made up of labradorite, augite and partially weathered volcanic glass, with minor amounts of magnetite. On the Mohs scale, labradorite is between 6 and 6.5, augite is 5.5 to 6, volcanic glass is around 5, and magnetite is around 6. That means the basalt at Giza is certainly no harder than 6.5 on the Mohs scale, but more like a 6, especially as the volcanic glass is partially weathered. As a comparison, the Aswan granite that was used in the Old Kingdom is estimated to be on average a 7, and this is due to the abundance of coarse quartz in the rock, meaning it's harder to work than basalt. So, now that we know the mineral makeup of the basalt, it means we know there are plenty of things the ancient Egyptians could have used to cut and shape it. Flint and chert with a hardness of 7 are very effective tools to cut and shape this rock. Quartz sand, which is also a 7 on the Mohs scale, will cut right through it when combined with water, a copper saw or drill. As well as sand, other abrasives available to the Egyptians were crushed quartz and garnet, both 7 on the Mohs scale, and also possibly emery, which is around 8 to 9, and corundum at 9 on the Mohs scale. In my opinion, emery does not get mentioned enough, but I think that in time, it will prove to be the answer to a lot of ancient stoneworking questions. Emery could well be the lost ancient technology we're looking for. Being between 8 and 9 on the Mohs scale, it is so much more abrasive than quartz. In terms of absolute hardness, emery is between 2 and 4 times harder. Using emery on Egyptian basalt would have been a very efficient and quick way to cut and finish the stone. Emery is a dark granular rock used to make abrasive powder. It largely consists of corundum, but also other minerals like rutile, spinels and so on. Emery was used in the ancient world since at least the 4th millennium BC, with emery excavated in context in the Cyclades, all the way back in the Neolithic period. Emery powder was also found stuck to bore cores in Minoan Knossos, dating to around 1600 BC, the cores being the waste products of stone vase manufacturing. Researchers Gorlig and Gwinnett also made silicon impressions of Minoan quartz seals dating back to around 1700 BC, and on removing the silicon impression, a black powder was stuck to it. This powder was emery. The delicate and intricate seal in question was incompletely drilled in ancient times, meaning a tiny core was still in place, and so it was clear that a small tube was used in conjunction with emery powder to make the seal. Emery was also used in ancient times in the Near and Middle East, and also in India. Using functional analysis and scanning electron microscopy, in 1983, Gorlig and Gwinnett demonstrated that emery was likely used in the form of a loose abrasive by the ancient Egyptians when producing their granite objects in the 4th dynasty. Excavations at the 18th dynasty city of Amarna in Egypt uncovered mineral assemblages found in emery deposits, so at least by the New Kingdom, it looks like a type of emery was being used in stone manufacturing. So, back to the basalt at Giza, and quartz sand or crushed quartz with water in conjunction with copper tools could cut and shape it, and there would be no great problem. Because it's harder, quartz can cut through any mineral inside the basalt, but using emery would have greatly sped up the process. In the Mediterranean and Near East, we know that emery was in use since at least the 4th millennium BC, so it's not a giant leap to believe the powerful Old Kingdom Egyptians also knew of its properties, especially because they had well-established trade networks going out of the country. The problem we have is a lack of direct evidence of emery use in the Old Kingdom, but in all honesty, there is also a lack of people looking for it. Not to mention the fact that excavations of major sites of Egypt first took place a long time ago, and artefacts and architecture have not been well looked after over the years. If they did use emery, we don't know if it was sourced locally or imported. The only known corundum deposit in Egypt is located in the Eastern Desert, where coarse-grained corundum can be found in various colours. Ancient mines were found at the locality, but as of 2014, not a lot of research had been undertaken. But emery could have been imported from the Cyclades, which was the main source of emery in the ancient world, where we know it was used since at least the 4th millennium BC. And this year, a very interesting new paper was published showing that in the 4th dynasty of the Old Kingdom, Egypt was actively trading with the Cyclades. In the tomb of King Khufu's mother, Hetepheres I, beautiful bracelets were discovered, and recently, scientists have analysed them in detail, and they were found to contain minerals of silver, silver chloride and traces of copper chloride. Amazingly, the isotope ratios of these minerals are only consistent with ores from the Cyclades. But even if emery was not used, quartz sand can still cut this specific type of basalt rock. And if we take another look at the basalt pavement on the eastern side of the Great Pyramid, it's not exactly incredible workmanship, looking more like crazy paving. Looking at these photos taken earlier this year, and we can see just how rough the cutting and shaping of the basalt actually is. This isn't the greatest work of ancient Egypt. But in all honesty, we actually can't learn a great deal by looking at this pavement today, because it is largely reconstruction work. This is how the pavement looked in the 1930s. Yes, it's quite different to today, with only a handful of blocks in situ, but most scattered around in a random jumble. Looking at this footage from 2023, and you can see how the pieces have been randomly cemented into position, and I'm sure that a lot of this reconstruction work was guesswork. I can't find any records concerning the pavement's reconstruction, but knowing just how bad historical reconstructions were, I wouldn't be surprised if some of the blocks were reshaped to fit the desired footprint of the old mortuary temple. Some of these cuts do look far too fresh to be 4,600 years old. When in Egypt earlier this year, some of the tour group were asking me about the saw cuts and clear signs of workmanship on the basalt, asking me how it was done. But my answers were always the same. We simply don't know who made them. Was it the work of a royal stonemason from the 3rd millennium BC, or was it modern work from the 1940s to reconstruct the site, using more modern tools? There is really no way of knowing. But long before the reconstruction took place, the great Flinders Petrie does note that basalt blocks were sawn and fitted together. He notes the blocks were laid on a bed of fine limestone, and that the Arabs destroyed the pavement to access the stone beneath. Some of the basalt blocks were used to mark the edge of a crude road or trackway that went down the hill on the eastern side of the pyramid, and these blocks were also found to have work faces. On plate 14 in Pyramids and Temples of Giza, Petrie shows 3 examples of basalt. The one that's labelled number 3 comes from the pavement, and as Petrie says, it's showing a saw cut that's run askew and then abandoned. Interestingly, he says that sawing dust and sand is left inside it. Number 4 is another piece of basalt pavement, and we can see regular and well-defined lines. Number 5 is a slice of basalt, sawn on both sides and nearly sawn in two. It's interesting that sand grains were found in the piece labelled number 3, as it gives us an indication of the abrasive used for working the basalt. But even though Flinders Petrie notes these cuts, even though they were clearly made before the restoration of the 20th century, we still don't know their Old Kingdom. Restoration work was done at Giza in the 18th, 21st and 26th dynasties, and the Romans were also active at Giza, as well as the nearby Abu Ruwash, tearing down Old Kingdom structures for the stone. The Arabs also used stone from the Great Pyramid for building. Therefore, we really don't know if the saw cuts on these basalt slabs are truly as ancient as we're led to believe. Some of them might be, but some of them certainly look too fresh in my opinion. Now, I'm personally more interested in the architectural feats, the finished constructions as well as the geology of the materials used, and I don't have any expertise in the tools used by ancient people. But I do like the fact that the YouTube channels Scientists Against Myths and Sacred Geometry Decoded experiment with ancient tools and technology, and what they've shown with a very limited budget is that igneous rocks can be worked with great accuracy. Nothing can and will ever be perfectly replicated, because the ancient Egyptians would have honed their stoneworking skills for hundreds if not thousands of years, passing on their knowledge and expertise from generation to generation, knowledge that is now sadly lost to time. But if part-time independent researchers can achieve these results, I don't doubt for 1 minute the Egyptians could have created this basalt pavement. The Khufu temple basalt pavement apparently displays the best examples of ancient saw cuts at Giza, but with the rock being between 6 and 6.5 on the Mohs scale, with partially weathered volcanic glass in its ground mass, well, it means a slurry of quartz sand, used in conjunction with some kind of metal saw, could cut this rock without a problem. And if emery was used, the operation would have been so much faster. And remember, the large faces were likely split along zones of weaknesses already present in the rock. It's unlikely they were cut. Only the edges of the basalt show signs of cutting. Ancient technology is a difficult and somewhat impossible line of study. All we do know for sure is that the materials were available to cut and shape basalt in ancient times. We just don't know the exact tools and techniques that were used. And how could we? There isn't some rich billionaire pumping money into finding the answer, so we are reliant on low-budget tests from independent researchers. But we are being shown that on a small scale, cutting, drilling and shaping granite was possible with primitive tools, combined with abrasives like quartz and corundum. So, if we can cut small pieces of granite in these experiments, the Egyptians could surely do the same as well. Their techniques would have been tried and tested, improved and honed for centuries, so I'm sure they would have found ways to scale up their operations. And because Old Kingdom basalt is softer than granite, because its mineral makeup is softer than grains of sand, I don't have any reason to doubt it was possible. To truly understand exactly how the Egyptians worked stone requires a hell of a lot of money. For the labour, the analysis, the stone and so on. Rogue billionaires by social networks. And the truth is, the money required to understand ancient stoneworking is never going to be available. We have to accept this fact in the 21st century, and that's why I personally don't get too concerned with this line of study. I don't have the answer, but how could I? How can anyone? All I can take away from all of this is that geologically, scientifically and theoretically, it was possible to cut granite and basalt with the materials available in ancient times. Small-scale experiments proved the science correct, and because I know that money for large-scale experimental work will never be available, I don't concern myself to try and find a specific answer, but that's just me. But going back to the basalt pavement, And again, because it's a reconstruction job with no sufficient documentation, we can't even look at the stone today and learn anything constructive about how it was originally cut. We have no idea who's been here in the millennia after the blocks were laid. These are the stones that should be analysed in great detail, the ones that were found in situ. But some of these stones could have been cut by later Egyptians, the Romans or the Arabs back in history, and they could have even been reshaped in the past century during reconstruction work. Provenance is so important. Still, even though it's reconstructed, the basalt pavement of the Khufu mortuary temple is a tourist attraction, and it was still great to see. I'm sure the original finished floor did look similar to how it's been rebuilt, and so it would have been an awe-inspiring addition to this truly great pyramid of Egypt. What I'm going to do next is compare the old and new pictures of the pavement, to see if the stones in situ on the old excavation photographs are still in place today. If so, these are the stones we need to analyse, because, in truth, these are the ones that could reveal the basalt stoneworking secrets of the Old Kingdom. Thank you very much for watching this episode of Ancient Architects. If you enjoyed the video, please subscribe to the channel, please like the video, and please leave a comment below. Thank you very much.